is Jeffrey Brody of the Smithsonian's Lemelson Center for the Study of Invention and Innovation, and we are thrilled to be here in East London to celebrate the 7th INNOSKATE Festival. We are celebrating the interplay between invention and history and skateboarding, technology, art, music, and design here in our 2019 festival, and we're just going to get kicked off, started right away. Our first panel today is something that's very important to us. We talk about the history of innovation and invention in technology in the skate deck. And we have three amazing experts who are going to talk to you about this, who I'm going to bring to the stage right now. The first is the professor, Paul Schmidt, and as you know, in his reputation, is of the grand master of all skateboard designers and builders. So Paul, come on out. There's no one on the face of the planet who knows more about the design, manufacture, and history of the skateboard and the technology and creativity in it than Paul does. He's going to be joined by Paul Sohi, who is an industrial designer with Autodesk, who looks at how new advances in design and manufacturing are going to perhaps change how things like skateboards get designed and made in the future. And to moderate this session, we have Ryan Clements of The Border, who is an amazing gentleman all around. So Ryan, I'm going to hand this off to you and invite you all to get going.
I'm good to go. Come on up here, Paul. Paul Schmidt, welcome. Good morning, everybody.
Hello. Yep. Okay.
So my name is Ryan Clements, like Jeff said. I work with The Border. I'm super proud to be a part of INNOSKATE. I got a call 6 years ago from Dr. Brody at the Smithsonian to come up and talk about skateboarding, which to me was like, what are we doing? I'm coming to Washington, D.C. to talk about skateboarding, and I've never sat in a room with more scholars and academics that had nothing to do with skateboarding, but everything I said about skateboarding, they understood every detail about it, and they just knew how to study it, and they knew how to comprehend it and respect our culture, and really taught me about how innovative we are in skateboarding. And when I did not even realize this whole life that I've lived as a skateboarder, we've been innovating this entire time. So we've done these programs in a few cities already, in Washington, D.C., Lakeland, Florida, Greenville, South Carolina, Seattle, Washington, and Boston, Massachusetts. I never thought the Smithsonian and skateboarding would ever collide. I went to the Smithsonian as a kid, you know, just checking it out as a normal tourist going to Washington, D.C. And then here we are working with them in London, and it's an amazing feeling to be here. So we have a great day planned, and this first panel, we call it, you know, when we started this program, we called it 50 years of skateboard innovation and invention, and now we're at 60. So it's been nearly 10 years that we've been doing this. So we're really going to talk about how we got. Paul, will you hand up that roller skate? Hold up that roller skate right there. How did we get from that right there to this right here? You know, how did we get from like? Well, actually, that's not the best example because that's the next.
That's where we're going.
That's where we're going. Yeah. How did we get from that to this? And you know, Paul's going to break down that part of it in detail. And you know, we're going to talk about essentially the history of the skateboard, where it came from, where it's going to, and then we're going to get into Paul. Mr. Sohi here is working on creating new skateboard trucks, which to me is even a little more interesting, right? So we're going to get started first with Paul Schmidt. But Paul, I don't want you to sit here the whole time and have me not bring any attention to you. So I want to talk about Mr. Sohi for a second. So he's from here in England, living in San Francisco. He works at a place called Autodesk, and you have a cool title of Iconic Projects Lead and specializes in generative design. So I'm like, what is generative design? I had no idea what it was, right? So I texted Dr. Brody. I said, can you just tell me? So I'm going to read the definition off to you, right? That's a design process between human designers and computer artificial intelligence. The human designer establishes the specs and performance parameters for something and creates an initial design. The computer then takes the specs, parameters, and design and computes about 1 million iterations and suggests the best solution.
Yeah, that's pretty much it. I just like to describe it as I have an AI assistant who helps me out and make sure I don't screw up, basically.
Yeah, that's definitely pretty tech, and yeah, because I didn't even know what it was, so I'm like, here I am needing to know the definition. So happy you're joining us here, and what I want to kind of get into first is Paul and let him do his magic here, Professor Schmidt. So I have a special connection to Mr. Schmidt because we're both from Tampa, Florida. Paul started skating in what year?
73.
73. I started in 85. So by the time I started skateboarding in 1985, you were gone. You lived in California already.
Yeah.
You were already doing your thing out there. So, you know, if you're a skateboarder, you have ridden a skate. I can guarantee you, if you've skated for any number of years, you've ridden a skateboard that Paul has built or his company and factory has built.
Or
Paul,
at least somebody that was mimicking what I built.
oh, there you go. Someone was copying.
That's guaranteed right there.
Someone's definitely copied you along the way. So this is the general question I'd like to start with, Paul. Like, why did you even start innovating? Why did you start inventing? What got you into doing this?
So the crazy thing with skateboarding for me is I was always a kid that made things. My dad ran a theater program, and I get to go use the power tools in the back shop and build a set and stuff. And so to me, I was always just making stuff, whether it was that or tree forts or whatever, you know. So as skateboarding came along in the 70s, and having a solid wood board like this was easy to build and obtainable, I built one, right? And then one day at the skate park, as we got into laminated boards, I went to the store one day of a couple guys, and they were pretty influential. One already had a pretty cool nickname, and it was Ollie. And the other one didn't have his nickname yet, but that was McTwist.
Oh, okay.
Alan Gilfin and Mike McGill.
All right, a couple of guys we know.
Yeah. And Alan said if rails slid, that'd be cool, because back then, the rails on a skateboard, being these plastic rails, were for grabbing, or they were made out of urethane. So when he'd rock and roll, the urethane ones would grip. And he's like, I don't want to grip, I want to slip. So that was my first product. And that started in 78. And by 80, I was selling them around the world. So I got pretty established. But the skateboard market was really small then.
Yeah, it was tiny, right? And so
It was crashing.
So you start with rails, and then how did you get into skateboard decks?
Took me 5 years of experimenting and trying. I went to a trade school, high school, and learned a trade. And I built sailboats and learned about lamination, and just got good enough to finally quit my job and say I'm just making boards now, right?
I love that. The moment you get to quit your job and do what you want to do.
Yeah,
that's a good moment. That's a good moment. All right. So what I want to kind of talk about first, or as far as what we have lined up here, break down what you're holding.
So this is a metal roller skate. I believe, if I remember right in my research in the past, these came out around 1888 was the first roller skates, okay? And what happened is the roller skate led to the scooter, okay? But when you couldn't afford a scooter or a skate, but you could get an old skate that was broken. So you see this adjustability, this slides, right? And they would break apart real easy, right? This particular one's riveted and I can't pull it apart, where a lot of them just had a screw and you go two pieces, right? So basically what happened is that they started to build these crates here. So you can see the wheels on the bottom of that, Those are the same steel wheels, Same mechanism as here, right? So this crate, they would take this fruit crate and make it up and skate it, in their scooter, So if you look at old movies and things from the 20s, 30s, 40s, scooters were a big part of society, just like they are again, right? It's crazy, things come and go, right? And so, but this was the home-built scooter, right? This is the I can make it myself scooter, However, if you look at mechanics and leverage, it's hard to attach this much mass up here to that on the bottom and keep it on. And then the reality is when you ride one of these, when I made this reproduction last year and I rode it at the Van Skate Park and I certainly found out about crate bite.
Yeah, I never heard of that.
And the crate bite, instead of wheel bite, the crate bite, I slammed, right? And it's like, I'm in my lab coat, riding my new scooter, and I get bit by the crate bite. It was so good, But what happened is if you didn't screw it together good enough, the crate bite broke your crate. And then you're like, well, how am I going to get home? I guess I'll just ride this board straight, That's the reality of what happened, right?
So that's what happened. So then what was the next step in skateboards? The crate part comes off.
Right, so the crate car comes off and you just ride this board, right? So it was very common. I had a couple of people last night share the story of, nailing a roller skate to a board, And even now there's like a whole group of guys that love to make a retro board and make it out of an old board and put a roller skate to it just because it's that maker DIY thing, right?
Absolutely. So that one, where'd you get that?
I bought it at eBay or a swap meet or something over the years. I don't remember exactly where. But this is a roller derby number 10 skateboard. So this is pretty much credited as the first commercial skateboard. This is from 1959. This is from before I was even born. Okay? I had nothing to do with this technology. Don't blame it on me.
Hey, so should we get someone to try to skate this thing?
Nah, the steel wheels on it.
Not gonna now?
Just
not that one?
Not gonna cut it, But as we move along, luckily we got rid of steel wheels and we got clay wheels and composite wheels, and it would be sawdust and resin and clay. And that was a better wheel than a steel wheel, and it now had some width. You see, it had some riding surface where the steel wheel barely had any, right? And it had better bearings, and it had a bearing cup. And this bearing cup design lasted all the way into the early 70s when we replaced it with precision bearings.
Gotcha. How about that one? Can we get someone to ride
Yeah,
that
we
one?
can get someone to
Let's do
ride this.
one.
So this is a board that I made for one of these programs, I don't know, 6 years ago or something like that. And this set of boards we're going to have people ride. There's a famous pro skater artist by the name of Neil Blender. So I asked Neil, can you decorate these boards with what you would think the era represents graphically? So to Neil, the 60s represented surfing, but you're a street surfer. The boards quite often have the same graphic top and bottom. That was common for that era. This board is just solid pine. Okay, it could be made out of a fence post or whatever. Kicktails don't exist yet. Concaves don't exist yet. Grip tape's not even part of it. You literally ride this thing barefoot and grab your toes around
So what tricks are being done on that?
Wheelies, tic-tacs, just surfing, fluing, cruising, not much. Because when you had a steel wheel, you can't turn very much or slips right out,
Gotcha.
right?
Gotcha. Hey,
You know?
Chris Colburn, come on up here.
Hey, Chris, all right.
We got
I heard your name
Cookie.
a bit ago. I didn't know you were here.
We got Cookie up here. He skated Street League yesterday.
Yep.
Joining us this morning. Appreciate you being here. So this skateboard, I'm thinking like maybe you want to try to kickflip it.
Yeah, I'll give
So,
it a shot.
Yeah.
so Chris's mind right now, you realize someone in the 60s, their mindset was what they saw around them, right? Chris's mindset is current now. Now, because I can't expect him to do anything on a steel wheel, all these boards have uniform trucks and wheels. The width of the trucks and the diameter of the wheels sort of represent the era they were in, right? So we've done that, but we've kept it where it's rideable and relatable because we don't want to kill him or anything.
Give it a
right?
shot,
You know?
Chris.
So what do you got on that thing? So notice he doesn't have much of a lever on the back. There's no kicktail on it, right?
Of course he could
Now
do
they
it.
weren't doing that in the 60s.
All
I
right,
guarantee
I want
you,
to see a
right?
tray flip. There we go.
Now realize that he's got that mastery of balance, right? And he's just playing off that truck because he's still able to pivot off that axle. He can't get the tail to hit the ground because it's just like super steep, right?
How about a nose manny?
You get a good manny out of it probably, right? Yeah, there you go. So that's a great example of where the mind is the controller, right? Like in the world of running, you know, they aspired for many years to break the 4-minute mile, then half a dozen guys did it that year, right? Like whatever barriers in front of man will figure out how to overcome it. And when he overcomes it, then he just moves on. He doesn't even count it anymore. It's just like, oh yeah, we're just moving forward, right? It's progression.
So then what was next?
So then this skateboard here is a skateboard very surfboard-esque. This is a Bang board. This is a production board from about 73. Okay, this has ball bearings in it. It has roller skate trucks, roller skate wheels basically, but now they're starting to make them for skateboards, right? Where before they never really got made for them, you know, and you could make your own flat board and buy these trucks and wheels and put it on it. So like a skateboard woodshop project in the first half of the 70s was very common to make a skateboard.
Yeah, so at that point you were drilling holes through the board using nuts and bolts, not just rivets or screws.
Right, yeah, so the other boards had rivets or screws, now it's bolted in, right? And as we move forward there, this board here is, you know, you might want to call it a penny board because the penny board is just a knockoff of what happened in the past, right? Like it's just an imitation of the past. This has precision ball bearings in it and very loose, right? You know, wheels are really wide, you know, plastic. So this is very similar to what my first skateboard that I purchased was. The first skateboard I rode, I don't remember if it was this or this, I'm not even clear, but I know the neighbors brought it home from a swap meet and it was a 60s board. And this was in the early 70s and I lived in rural Wisconsin. And I lived in a 100-year-old farmhouse and they had a brand new house, so they had a smooth driveway. You could ride it there, you couldn't ride it anywhere else, right? And then when I got this urethane wheel board, I could go out in the neighborhood and ride the hills and stuff. And it was fabulous because I was into sledding in the winter, so this was my form of sledding in the summer, right? You know? So that's an example there.
So that had a kicktail, but and were the wood boards being made with kicktails at that point?
So the kicktail got patented in 1968 by Larry Stevenson with Makaha Skateboards. He never got the opportunity to protect that patent because getting a patent and protecting it are two different things. And then when the logic of everybody says, wow, that's great, I want it that way, you know, people just follow it, right? And then you can try to legally protect yourself, but the reality is that it's hard. I had discussions with Larry's son about it a couple years back, and he's like, nah, Dad was cool with it. He knew that he was just progressing the product, you know? Because Larry did a lot of stuff in skateboarding through the 60s, 70s, and even in the 80s. Like Power Edge magazine was Larry Stevenson.
Oh, okay, gotcha.
Yep.
So talk about the next wood board. Yeah, there you go.
Right, so here's a solid wood board that has a glued-on kicktail. Now look, we finally got grip tape. How about that? That helps a whole lot, right? Let me tell you, the grip tape really helps with the tricks a lot. However, this is that rubber stuff like you'd have in your shower, right? You know, not that good. Doesn't even cover the whole board because they don't make it in big wide sheets. It's little strips for your shower, right? You know, so but this board is a reproduction that I built. Here's what Neil thinks that was going on in the 70s was the band thing.
And that's cool.
You know, no doubt about it. Chris, what do you got on this thing?
I'm thinking.
So now we got a kicktail. What do you think you can request out of him, Ryan?
I was gonna ask for a nollie flip.
A nollie flip?
Only big spin.
So we'll see if we get a nollie flip out of it. He doesn't have much nose on there, but we saw he figured out the leverage protocol off of it, right? Trucks are similar. Oh, it didn't go anywhere, right? He didn't have a lever. Now he rides it backwards.
There we go.
You just turn it backwards, and it's like a Swiss knife, right? There's a different end on each end, and you know you can use those mechanics and that leverage to your advantage, right?
Danny, you want to take a shot at that board? Danny Fuenzalida, thanks for joining us this morning. Another
Thanks
gentleman in
for
the
coming
Skated
out.
Street League, fellow Floridian. There we go. That's it.
So notice the traction of the feet. There's no grip, right? He's just like, there's even grip tape, and he's still just slipping all over the place, you know? So it's really interesting to look at the progression of the skateboard. It's okay, you can chip it and nick it, it's okay. It's just a Neil Blender original, that's all.
No.
Yeah, no big deal.
Yeah, no big deal, yeah. So here we go on a board. This is a board I bought off eBay. This is a Stacy Peralta Warptail 2. So this was the first mass-produced laminated skateboard.
What brand made that?
GNS.
GNS,
GNS
okay.
surfboard. So Stacy rode for GNS. I had one of these as a kid with half tracks and Kryptonics. This one has full tracks on it, which is a wider version, and the half tracks were narrower. So this is laminated now. Notice my grip tape. It's got that super sparkle grip tape, right? And that super sparkle grip tape we would know now is cheap stuff, right? And that cheap stuff is because the grit is aluminum oxide, not silicon carbide, that good black, deep, grippy grip, right? You know? And you need some grippy grips so you don't slip around on that stuff, right?
Yeah, of course. And then that's all worn away and just,
Yeah, this
it kind
is
of falls
worn,
apart.
battered, battered. I actually love to collect boards that are ridden, not even knowing who wrote them, because I think that they first of all, there's still life in this thing. It's not even dead yet, right? It's
Where'd you get
cool.
that one?
eBay or something, I don't remember. This one, though.
This one, you didn't have this one at the last INNOSKATE, did you?
I'm
This was new
yeah,
to me.
This was new to you. Yeah.
Okay, yeah.
Ryan's like, well, what'd you bring that box for? You know, I'm like, I was putting it together with trucks and wheels. He's like, what are you talking about? No, this is where we're from. This is where we came from, right? So this is a new one I added to my collection a while ago. I don't normally buy boards for like $800 that are broken. The bolt is sucked through the board.
This one's special.
This one's broken right here. But this shows the attempt at technology, right? This thing's got a urethane bumper all the way around it. It's got P-Tex top and
So
bottom. It's got fiberglass.
The bumper is the same thing as the wheels. Same material as the wheels.
Same material as the wheels,
Yeah.
exactly. It's urethane. You see the color's even similar. The same company made it. However, I guess their process control of their batch coloring wasn't very good. I don't know. This one was in the sun or
I
something.
think it was originally the same green.
Yeah, originally it probably was, most likely. Most likely it was.
And what's in the center of that board?
There's foam in the middle of it. So it's not solid wood. And you stand on it, it's very vibration absorbing. It doesn't return energy. It doesn't give it back. And a good skateboard has to give you energy back. You put into it and it gives back, right? Yep. So it's a very interesting thing. But in this era, in the 70s, they were willing to try. I mean, we went all the way from, you know, this to this in the 70s, right? All this level of progression. And by the time we got to the 70s, the skateboard was 10 inches wide, right?
And so I just found this out last night when you and I were talking. So we talked about this board with the foam, and then I was like, oh, and then you're like, oh, I made foam. I had no idea that you did that because I started skating in '85. This board is from '83.
83, 84, yeah.
Yep. Talk about that one because I found that interesting.
So this is my attempt at technology because as a skateboard enthusiast, you're trying to make good stuff, better stuff, whatever, you know. And this is full of foam in the middle. However, it's wood on the outside. You can't see the foam. You can't see the fiberglass. There's no urethane bumper. I actually made a urethane bumper board like 5 years after this or 8 years after this because I was still trying to imitate this one because it was so rad.
You thought it was cool, yeah.
Yeah, it was so cool to me, you know, and it's part of that technology thing and part of material science and understanding materials and how you can get the best out of them.
Yeah, so then this board's the replica here. This is the one that we're going to skate. And this
yeah,
thing
so this is the one we're going to skate.
How wide are these boards? Talk about the concave.
So this board is 10 by 30, okay, and that's the average skateboard in the 80s. This sort of board could represent from actually 79 to 87 for a company that wasn't very progressive.
Basically the first skateboard I rode in '85.
Right,
essentially
this
that.
era. So we got half-inch risers on this thing, really big wheels, really wide trucks, really heavy.
Yeah, that thing's massive.
Right?
Cookie, you want to give a shot to this one
foam
right here?
one's a lot lighter, but I'm not going to let Cookie ride that.
Yeah, that thing's precious.
That one's precious, exactly.
There you go. Maybe a tray flip on that one? That's a big boy.
Yeah, now look at the graphic.
Yep.
Another Neil Blender original. Launch ramp, jump ramp.
No board slides. No, I'm just kidding. Do whatever you want on it.
Yep. So now the board is so wide, the context, you saw the little board, he had a better attempt on that without a kicktail. But that's the amazing thing of the adaptability of skateboarding, because you see him, and each time he tries, he gets better and better and better. So a guy tries a trick, and he's adapting and adapting, adjust, adapt, adjust, right? And it's amazing what happens in skateboarding and how that goes. You want to give that one a shot, Danny? Come on, it's more similar to what you're used to.
Hey, Gabriel, you need to get up here, too. Gabriel Fortunato. Hey, man, how you doing? Come on over here. I want to see you skate this board as well.
Just look at the reaction on his face. Like, I love the reaction of people. So everybody always wants to try to kick flip, tray flip, you know, push the boundary on an old board, you know, and it's almost like the mind. Oh, yeah. Now, see, he had a kicktail for that. He had the leverage. He had the mechanics, right? You know? Yeah, right. But you see that adaptability. That adaptability is amazing, you know, and what happens in skateboarding.
So then it goes a little bit to talk about this. What's the year differences between this Chris Miller and that board right there?
So this Chris Miller is 87. So this is a Schmidt-Sticks board. This is a board from my brand. Now we can see we still got sparkly grip tape. However, they were die cut then, and they came in from the edge. So this one has die cut tape, right? So it's part of that change and progression. We still have big round-headed bolts on it.
So did that board come with the grip tape on it, or did you? No.
But they would sell die cut shape to
Gotcha.
grip tape to match major shapes.
Because there weren't that many different boards made. Imagine trying to do that now.
Yeah, now it's impossible.
Yeah, it'd be impossible.
Exactly. So this board has some Schmidt-Stick saw blade wheels on it, and it's got some tracker trucks with plastic base plates on it, you know. But the big difference about this board is we now have a concave that's parallel. We can see a bit of a hip here. The shape is narrow on this particular one, and a hip here, and a kicktail on the nose. So now we have leverage. Now we have that tool, right? So this was the start of that I took the plywood of a board and changed it. And a lot of the people who made skateboards before me were like manufacturing people. They weren't skaters. And they're like, well, that's cool. We can't do that in production. And it's like, well.
You're like, I'll figure it out.
I'll figure it out. I got to make it. Like, I'm riding it. You know, it's like I'm making it for me.
And during that era, like, how many skateboards a year were you making at that point? In like the late 80s?
A lot. I mean, I ran the factory for Vision and Sims that I'd set up, and it was 1,000 a day type thing.
Yeah.
You know?
Okay. And then I always find this fascinating. What was the most you ever made
most
in 1 year?
I ever made in 1 year was like 2001. It was like 96,000 boards in a month.
That's
My
insane.
factory ran 24 hours a day, 7 days a week.
That is unreal. Over 1 million boards.
Yeah. I didn't make the million part. I missed it.
Oh, you just missed it.
I just missed
Okay.
it. I was aiming for it, and then the industry slowed down in July, and I was selling so much because of establishment, and I could tell that it was happening because I saw it happen in the 80s, right? And
Yep.
I ratcheted it all down, and you know the industry didn't figure it out till December that there was no more race.
Gotcha.
The race was over, right?
Yep.
You know?
And then we moved from that to what year? What year did this what we call a popsicle shape
Right.
now.
So what we call
But
a popsicle now on the average board, this is sort of an early 90s. And when we look at a skateboard from the early to mid 90s, it looks now just like it did then. There's not any change to the layman's eye. You might say there's more fingers of flat from the bolt holes to the bend. You might say there's a little more concave depth. But we see the black grip tape now. This is a silicon carbide. This is sharp, black, stays good, you know, wears out your shoes, eats all your stuff up, the good stuff, right? You know? And so this board very much is just what, like anybody's riding here today, you know? And
so from
I've done
1990
refinements since then.
Yeah, that's what I was going to ask. So in essentially 20 years.
Right.
It's like,
so in the
or
last
30,
20 years,
30
it's been
years.
very stagnant. In the last 20, it's been very stagnant. Have we done things with molds and curvature and concave and thickness? Yes. Structural optimization. If I go back to a board from the 70s, it had 60% of the grain going long and 40% of the grain going cross. And as we moved along, it got 70-30 in the 80s. It got 75-25 in the early 90s. And then in the late 80s, I got it to 80-20. And that was all because of one trick. Goes back to my origins, goes back to the ollie, right? You know?
Gotcha. Can we get the guys on this
Ollie's
board?
been part of my career the whole time along.
Obviously, we know what's going to go down on this board, but let's see the dudes skate it and see how easy they adapt to it, or don't even need to adapt.
More Neil Blender,
There you
exactly.
go, more Neil Blender, straight from the 90s.
Straight from the 90s. The first set of boards I made for the first event at the Smithsonian, Lance Mountain did the graphics on them, and they were super cool. And the same thing was like, what's your impression? See, so it doesn't, there's not even really, it's not his board, his trucks, but it's so close that a basic stuff can happen real easy, right? Notice his feet aren't sliding on the board anymore. There's lots of grip, you know? And it happens real easy. So
Hey, I have one question I want to ask is that
Okay.
as you made these little changes over the years, like you're saying, oh, you know, there's a little room in between this, or you know, a finger between, you know, between the end of the bolts and the tail. What initiated those changes? Was it the skaters? Was it you?
Well, realize
Like-
that everything is the skaters, right? I'm just a skater myself, but it's by being surrounded by people. It's by seeing what's happening and reacting to what's happening and hearing feedback, you know. So I had a pro team. I would run contests. I would build ramps. So I was so part of the scene that there's no way I couldn't pick it up, you know.
And then now, from what I know, like skaters come to you all the time and design their own specific skateboard, right?
Yeah.
Like that's very common.
Yeah, very common.
So like Danny Way, you know, you created his board that he jumped the Great Wall on.
Yeah,
like that sort of
luckily he called me 3 days before. Somehow they got all the wood over there and the ramp built, and he just 3 days before.
couldn't figure out the skateboard. So that's the kind.
He
That's what
calls
you're
me,
working
hey,
on.
I'm going on this trip, and it was like, dude, those are special plywood. Luckily, I had like 2 pieces of plywood left. I only got 2.
You know, one thing you told me one time, it was someone that was trying to nollie farther. It was maybe it was a Darrell Stanton or someone like that.
Yeah.
They were trying to nollie this gap, and you're like, oh yeah. So I made him a longer nose so he could ollie.
Well, I didn't actually make him a longer nose.
What'd
He
you-
had 2 setups in his car.
Ah.
So he was in a parking garage in his neighborhood, and it was roughly 1 level up, and there were stairs and a handrail, sidewalk, grass, and a curb. And he'd been trying to do this gap for 2 years, and he was missing it by 2 feet for 2 years. And I analyzed the 2 boards, and one had shorter wheelbase, longer nose. They were the same length, but the math was different, right? And I go, well, my analysis is this one has a 10% advantage to go forward, and he's jumping up and down. I was missing it by 2 feet for 2 years. This is the bomb.
That's the one. Yeah.
You know?
That takes someone like you to look at it that way and, you know,
Yeah, and
break
then
it down.
You know, you could change your wheels to make the way your board reacts. If you put smaller wheels on, the tail hits sooner, and that's better for manual pads and that kind of thing. But believe it or not, if you want to get up on something high, a bigger wheel is going to make you taller and give you more leverage, and give you more mechanics.
That slightly shorter tail too, because it gets you get a little more vertical.
Shorter tail,
yeah.
a little more vertical.
Those are-
So
yeah.
in a sense, I have this little tool in my pocket here that I'll take on a board, and I'll put on it and check the angles. So for instance, if we take this board here and we check its angle, this is a 80s board, right? It's got a really steep tail on it, and it got riser pads on it, big wheels. It's a 43.3 angle, and that's the result of the truck, the wheel, the riser pad, the angle. There's a triangle of leverage here, right?
And then what's the 90s?
So the 90s one is going to be probably mid-30s. However, I've been seeing it go up lately with guys. Their numbers going up.
Oh, is that right?
But I've only had this tool and this mindset. I've been practicing my whole life. I only got to this like 2 years ago. I was trying to solve a puzzle called PJ Ladd.
Oh, okay. I'm sure that could be difficult.
So this one is 35.9 off the tail, right? Is that the tail end? Yeah. Now let's see what it is off the nose. Nose is usually a little bit longer than the tail. And what will happen is this becomes the leverage of the mechanics of what's happening, right? So that's 35.2 off the nose, right?
Gotcha.
So if the board was truly symmetrical, you asked me about that earlier, why isn't it the same on each end? And I'm like, well, why would you want a pocket knife with one knife in it if you could have a pocket knife with two knives?
Yeah, different functions.
Right? And a lot of times the guys will go, well, they're talking about tricks and what's working and what's not. And I'm like, well, you ride your board back. Yeah, I do that trick on my board backwards. Why? Because it works.
Yeah.
Well, do you know why it works? No.
And you break
I
down
try
why
to
it
educate
works.
them and teach them that, right?
Yep.
You know?
All right, so we've been leaving you hanging back here, Mr. Sohi. All right, so I guess my I didn't know what you did before I read about you, and then I met you last night, and you brought your trucks today. Oh, go ahead. Go ahead.
So the neat thing about this thing is the willingness to try. So let me go back a little bit to why this didn't work in skateboarding. Well, we could say it's broken, right? But all skateboards break, right? Like,
of course.
It could have been engineered not to break, but also the reality is somebody wanted to make it and they made it. Was it viable or commercial success? Did they make money doing it? No. You know, it's like me making these. They were fabulous skateboards, right? And the guys that wanted them, you know, like every time I see Gons, he tells me about a story when he was riding a foam core. And there's a picture at that ramp, you know, him riding one of those. Because I used to build all the boards for all the Vision and Sims team riders.
Oh, okay.
They all rode Schmidt-Stick skateboards with Vision and Sims graphics on them in the 80s.
Gotcha.
Because my molds were progressive and my
Yep.
constructions were. But why didn't this go forward? Well, first of all, I had a problem now. I had success, and I had to make 1,000 a day. It's really hard to make 1,000 a day this way. And then the reality is, when it costs double the money to make and you sell it for $2 more, it's not a business
Yeah,
proposition.
you can't do that.
And then the greatest thing about skateboards is people want their skateboard to be replaced and get a new one, right? Who wants a board that's going to last forever?
Yeah, we all like to go through. I think that's why the people that make the boards with the replaceable nose and replaceable tail now struggle, because like we don't want to ride the same skateboards for years
Yeah.
on end. We
Yeah,
want to change it out. It's a
Yeah.
progressing art form of like, yeah, we get a new one, we wear it out, we want a new one. That's what we want.
Right, and a lot of that comes down to the way a board feels. And when you go load it with foam or composites and things, it reacts different. The sensation's different. And skaters aren't willing to face that challenge. And that's the interesting thing about going into this product here that Paul's working on. He's not hindered by experience.
I love that because, you know, we were talking about that earlier, and Paul, I don't want to talk for you, but it's like, I looked at it, my first question was, why? What made you think that, like, I'm going to do this? So look at the skateboard truck, and Paul, please take over.
Yeah. So I'm going to start by saying I used to skate, which is, that's the real why. I broke both my ankles and I have arthritis in my right leg now, which is why I don't skate anymore. But this is really tempting. But when I skated and when I watch skaters today and we look at the evolution that you've been talking about, we've innovated and we got to a point where everyone sort of passively agreed, like, this is cool. Like,
Yeah, well, it's so highly refined.
Yeah.
So one thing about a deck is I talk about these composite boards and material science and using that to your advantage. It costs money, right? So what makes pop in a skateboard? Do you know what makes your pop? Everybody knows when their pop's gone, right? The board's dead. You tap it on the ground. It just doesn't sound right. It doesn't react as good. What pop is, or the way I equate to pop, if you had a soda with a straw in it and the straw had a crack in it, you're like, and it's not very satisfying because you're only getting about 50% of what you want, right? It's like, you know. And there are millions of microscopic straws in the wood, okay, and those little tubes get broken. So I talked about grain orientation. Most of those straws are going with the grain, and as we do tricks, we eventually start to break them. Even though it's not broken as a board, it physically doesn't look broken. Microscopically it is. And it's part of material science and part of nature, right? And so what are in there is this, in the world of composites and high tech, they talk about nanotubes. So the jets, airplanes, and plastic parts, about nanotubes. And these little tubes are so strong because if you put a hollow in there, it gets stronger than a solid. Because if you had a piece of metal pipe that was a tube, it will bend and flex back. The solid one will bend and stay, depending how it's treated or something. So what I'm trying to get to is the organic nature of the material. So I have Mother Nature's material. It's full of high-tech nanotubes, and it's got the same grain in it had when it was growing in a tree. Man didn't have to process it too much, okay? Those high-tech composites, man had to go through 10 layers of processing to get there. You got to pay for that, right? Nobody wants to pay for that. So the challenge now with this product is how to make this work. But because he's not hindered by making it a commercial success, he's in the idealism of designing and making something and bringing relevance. He may make the breakthrough that I can't even make because I'm too hindered by being in the cool,
You're
right?
in business.
I'm in business.
I got people to pay.
I got people to pay.
Paul, please
like to make
talk about your
stuff.
trucks a bit. Yeah, there you go.
So the desire behind this was like looking at the way that skating has evolved, the way that tricks have evolved, how we think about the interaction between the person, the skateboard, and the environment. And like the way I look at it is that this is my tool, and everything that I use is the environment that I express myself through with this. But we've gotten to a point now where there are certain limitations, like our imagination can take us so far. You mentioned it earlier that like the mindset changes when you see one person do it, then you realize you can do it too. Like the 4-minute mile or the first time an ollie was pulled off and now
Right.
everyone's doing it. It's the same thing with this. I wanted to create something and give people new opportunities to explore. And I feel like the time is right. Like next year we're gonna have skateboarding at the Olympics. And science and skateboarding have never really gone together at the user level.
Hey, wait a minute.
Well, at the user level. At the user level. And the drive behind this, and the drive behind a lot of the stuff that I do is how do you demystify, and like how do I go from this as step one to a future where if I'm going out and I do a session, and I want to like nail my tray flip. Wouldn't it be useful to me to be able to like look at something and it's like, all right, you attempted 50 tray flips and 42 of them you landed bolts and 8 of them were sketchy. This is the first step towards that of can I make it easier to ride? Can I make it easier to get the board into the air? Can I use less energy so I can ride harder and for longer?
So it's lighter.
Yeah.
And is it the same turnability?
Yeah.
Yeah.
Your ability to turn on this is not impacted. It's still the same silhouette as this. Again, you brought up nature, and what I think is kind of interesting about that, like generative design, is essentially trying to tap into nature as an engineer. So nature is the best engineer in the world. It's had a few billion years.
There's a
head
whole
start on us.
design world going on in manufacturing things that's really trying to mimic nature and that whole conscious. What is that gen year called?
Generative design.
Just generative design
Yeah.
is the nature design. Okay,
So-
as a whole. So that's what I was trying to get to with the tubes.
Yeah.
I already got nature's best stuff for what I make.
Right, and I've got to try and put that into metal. So
Exactly.
when you look at these, and you can see that they're just full of holes, and it's hollow like that. But if you come up and look at it closer, and you look at it against one of these, you'll see that inherently it's still the same thing. It's just that by analyzing this, and so the way that I made this is I basically give the AI a series of scenarios. So I'm riding in a straight line, I'm turning left, I'm turning right, and sudden impact from landing a trick. Then I tell it what materials I want to use and how I'm going to make the thing. And it basically goes through thousands of different ways to produce that until it comes up with the best possible solutions, plural. These two are exactly the same in the sense that they will do the same thing and they're going to perform the same way, but they look different. And it's just because there's no one perfect solution to anything. There's millions of designs that work, and I think that's what's really cool about it.
And now these hangers are titanium 3D printed, correct?
Yeah, so like you mentioned, I'm not limited by trying to commercialize this yet because I'm really exploring the technology, the viability, and moving towards a manufacturability stage. So,
But if you got your own titanium 3D printer by chance with
Yeah.
the bed size, that's
yeah,
big
then I can
enough,
hook you up.
Yeah,
But-
of course.
you'll get the
Everyone's
file
got
that
one of
makes
those.
them.
Right.
Hey guys, we're getting short on time here, so I want to kind of Paul wrap up your thoughts, and then Mr. Schmidt wrap up your thoughts, and we'll kind of close this one out.
So the future I see with this is trying to like push innovation and get people to try new stuff. A bunch of people have come up already and they're excited by this, which is great. If I tried to do this 10 years ago, I would no one would have even looked at it. They'd be like, that's weird, I don't like it, screw that. But I think we're moving to a stage now where people are open to the idea of putting a little science into what they do.
I would
and
agree
that's
that
awesome.
people are much more open to things, how they're made, what's happening with them.
Yeah.
You know, where sort of the 90s or the first 10 years of the 2000s, more like how quick can I buy it and throw it away? And now it's like, well, how can I buy it and get it keep and last and get my value out of it?
Yeah. And just to finish up, these are crazy expensive. So it's $1,300 each.
Is it okay if I have
But
Chris ride them?
Yeah. Yeah, go for it.
So we're going to see how Chris's body
yeah, let's do it.
reacts to these
then-
lightweights. So feel this thing. Now that's the same shape as this board, same size wheels, same bones wheels, right? But instead of Indies, we got these titanium 3D printed trucks.
And they're nearly indestructible as well.
I don't know, Chris.
What
do you think?
what are the regular skateboard trucks made out of compared to this?
So-
While Chris skates that.
Yeah, so regular skate trucks are made either of an aluminum alloy or a steel alloy and a stainless steel axle. So with the ones that I produce, they're titanium hangers, and it's the same stainless steel axle that runs through them. The next stage for me, in terms of, yeah, no, go for it, man. To make it more affordable and like viable for the future is changing the manufacturing up. So I wanted to finish these in time. Unfortunately, I couldn't. Those ones are 3D printed. This one is machined. So that's $1,300. This is $300. And then eventually I could get it down to costing. And so it's actually a viable product again. And like that's how innovation in anything happens, right? We just keep hammering
The
stuff at the wall
willingness to
until it
try
sticks.
is everything, right?
Exactly.
If you don't try it, then it's just never going to be.
Yeah, that's what I've learned through this whole INNOSKATE experience is that, you know, you need people to just go out on a limb and say, I want to try this. And then that's how we end up with improvements and innovation over time. Yeah. Hey, I want to thank both of you guys. We could do this for another hour. Paul Sohi, Professor Schmidt, thank you guys very much. Danny
you, guys.
Fuenzalita, Cookie, thank you guys for coming over.
So guys, I'm going to have these out on the table over next to Far Academy all day, and you guys can come look at all these variables and ask questions and that kind of thing as well. You're also welcome to come up now. How quick is your next
Oh,
panel?
the next panel, we're going right into it.
Okay,
Yeah,
so if I could get the kids from the Far Academy to come take this over to your booth, that would be great.
yeah, our next panel is up.